Welcome to Lab 33 for Honors Chemistry, Microvoltaic Cells. In this lab, you will be constructing a series of electrochemical cells by using 5 different metals and their corresponding ionic solutions. In order to do this, you will need a vernier probe wear setup that includes the leads, the metallic leads that you have not yet used this year. The 2 leads will be different colors, one red and one black. If they are connected to the cell correctly when you are all set up, then that means you will see a positive voltage on the screen. If you do not see a positive voltage, then you must reverse the leads. That's first and foremost. Notice that the red lead is the positive, and that's the cathode. You will have a black lead, and that's the anode. Notice my use of language here. I'm using the word lead. That's the metallic end. That's not the word lead. When you see the positive lead and the negative lead, that's the little metal ends you will see me use in the video. Take a look. This is the equipment you will need to do Lab 33 in Honors Chemistry, Microvoltaic Cells. So you see you're going to start with a piece of plain white filter paper. You'll have scissors, you'll need a pencil, not a pen. A pencil is preferred. You're going to cut out triangles, wedges, from the middle of the filter paper so that you can have copper, silver, lead, iron, and zinc arranged around the arms of this cutout circle of filter paper. Next to each labeled arm, you're going to place a piece of the metal. So you can see I took out of one of the containers the silver. I took a little square of silver. I have that here. Same with the lead and the other 4. So I've set those out. Now next to each piece of metal, you will also see that you have a bottle of solution, a silver nitrate here, copper, zinc. They're all the different nitrates of the different metals that you'll be using for this lab. I also have ready my vernier probe wear. You can see that it's hooked up, and right now with these 2 leads, the red and the black, right now they're not touching. It is reading 3.2 and change. Then when I touch them together like this, you'll see that the voltage drops. Now there it is. It's nearly 0. It's going to be super low. I'm not able to maintain good contact with one hand. Sorry. Filming with one hand, talking, and moving around with the other. So you can experiment with those a little bit and know that these are the 2 important leads that you're going to use once you have prepared your surface. So here's your filter paper. It's sitting on the lab counter bench. You're going to add drops of the individual solutions. In this case, I have silver nitrate here. I'm going to add those drops right here, right on the end of this arm. I'm going to do the same for the other 4 around the perimeter, and then in the middle, I'm going to put my sodium nitrate. That goes right here in the middle. So this will all be soaking wet with solution, and that's good because we need water to allow the ions to flow. Once you have your metals, once you have the solutions down, you can put the metals in place. If they're not nice and shiny, like silver, you can see it's nice and shiny. Copper's not too bad, but when you get to something like iron, you may find that the piece is actually kind of corroded looking. So don't be afraid to pick up a piece of sandpaper and give that a good sand. Scratch off some of that rusted coating there. You're going to need 2 hands to do this. I, of course, am only using 1, but then you're going to be able to put that iron and the zinc and the lead each in their place on the arms of the filter paper. At that point, you will then be able to take your leads and touch them between the 2 that the lab instructs you to do. So I'm going to have 1 lead here, and you're going to need 2 hands. I can't do this with 1, but okay, so you see me struggling with the 2 different leads, the red lead and the black lead. I'm only using 1 hand, but you will have 2 and you will have a partner to work with. When you begin this lab and you're hooking up the leads, put the copper, the red lead, in contact with the copper, and you're going to use the black lead in contact with one of the other 4 metals. It could be lead, it could be the iron, it could be the zinc, it could be the silver. And each time you're going to pause for a few moments while the vernier display settles down, wait a few seconds, take a voltage reading, and then move on to another metal. You will end up with readings for all 5 different cells, actually 4 different cells, all referencing copper with the red lead and silver, lead, iron, or zinc with the black lead. In data table 2, you're going to rank the 5 metals in terms of lowest reduction potential or highest reduction potential. When I say low reduction potential, that means that this metal is more likely to be oxidized. The one with the highest reduction potential is more likely to be reduced. So perhaps that will help you in ordering those 5 metals from lowest, the most negative potential, to the highest. In part 3 of the lab, in order to fill in data table 3, you're going to be attaching the positive terminal, the positive lead, the red lead to the more positive, and then again the black at the negative. Use the data from part 2 of the lab to try to establish those different potentials using different metals. So I'm scrolling down to data table 3. I'm hoping you can see this because data table 3, if you can't see the screen, hopefully you have your lab in front of you. It shows that you're going to hook up silver and lead, silver and iron, silver, zinc, and all possible combinations of these 5 different metals. You will record what metal you have at the anode. Anodes are negative. What's at the cathode? That's the positive terminal, and what voltage you see as a result. Once you have done that, and you have finished measuring all the possible potentials across the electrochemical cells, you may pick up the filter paper off the lab bench, throw it away in the trash can, wipe up the area where you were working, and make sure you wash your hands because they will probably be wet with various ionic salt solutions, and you want to make sure that you rinse those off and clean your hands well before you leave the lab. Lastly, the metal samples. Each of the metal samples we want to keep. I'm going to ask that you wash them off, that you rinse them well with water, wash them, and then set them on the counter over by the windows to dry. I will have labeled areas for each of the different metals, and you're going to put them over by the windows, and we will reuse them for the next lab. Good luck!